Hello everyone, this is another video on the STM32 tutorial series, and in this video I want to show you how to use the FreeRTOS middleware. And it doesn't matter which STM board you're using, the concept is the same as long as you're using CubeMX. So what I'll be showing you today is just some basics about RTOS. I'll show you how to create multiple threads and how to use a semaphore, mutually exclusive semaphore to be specific. So let's start by opening CubeMX. And on CubeMX we click on New Project. Unselect the right board. In my case it's the Nucleo, but in your case it can be any other STM board. The concept is the same really. So go to board selector. It's a Nucleo 64 pins and it's the F4 version. It's the F401. And under the pinout, the first thing I'll do is that I'll clear all the pinouts and I'll enable them manually. So PA5 is for my LED, so I'm going to enable it and set it to GPIO output. And PC13 is the push button, so this one is the GPIO input. And I'll enable a UART line, UART2. UART2 connects straight to the ST-Link, so you just plug in your Nucleo board to the to your PC, and it's going to show you a COM port. But for other STM boards, you might have to connect a TTL to USB converter. So I'm going to enable UART2 anyway, asynchronous mode. And now I need to enable my FreeRTOS middleware. So go to middlewares and expand FreeRTOS and enable. And one other thing I'll do here is that I'll change the system time-based source from the SysTick timer to one of the general purpose timers. The general purpose timers allow us to change the tick rate of the RTOS. So I'm going to change it to timer 3. You can use any other timer. Now let me go to configuration and my UART. The baud rate is set to 115/200. I'll leave that as default. I'm happy with this. Now let's see my FreeRTOS config. So for my FreeRTOS, I need to add a task first of all. So this is the default task. It's called a start default task. I'll call it thread 1. And the stack size is 128. It's fine. And I click OK. And I'll add another task for my UART or LED perhaps, and I'll call it thread 2. Stack size is the same as well. And I'll add another thread manually when I get to Keil IDE, just to show you how to add task or threads manually. Now I need to add a semaphore for my UART line. This is important because UART is a shared peripheral. Multiple threads might use UART. And in this case, if two threads want to use UART, this is a problem because they cannot use it at the same time. It will either be the faster thread will always acquire UART line and the other thread will never have an access to the line, or if the other thread started using UART while the first thread is using it, this can cause the system to hard fault, and this is a problem. And to avoid this, we use a Mutex. What Mutex simply does is that if any thread want to use UART line, it will add it to the queue and it will schedule it, it will handle UART line over to it as soon as the first thread finished using UART, and so on. And to add a Mutex, just click on add here. We're going to give it a name UART Mutex. This usually represents the peripheral that Mutex is used for, and click OK. You'll get more idea when we get to Keil IDE. Okay, that's all I need to do here, so click OK. And now we're ready to generate the source code. Click on generate source code icon and select a location to store your project in and give the project a name. I'm going to call it FreeRTOS video and select the right IDE, Keil Macrovision 5 in my case, and click OK. Once the source code is generated, click on open project and this will take you to your IDE. And on Keil, expand this project folder, application user, and open the main. And on here, scroll down, you'll see that two threads has been defined at the bottom. So we have thread 1 and thread 2, and both are empty, so I can enter my code straight to here. And the first thread, let me just toggle an LED and transmit something over UART, perhaps just hello world. So this will toggle my LED, and now let me transmit over UART. I'm going to define a variable to store my UART data in. It's an unsigned 8-bit integer. I'm going to call it TX data, and it's of size 20 perhaps. And I'm going to write hello from thread 1. And I'll add a carriage return. And these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, good. They're exactly 20. 20 data points. And I'll transmit this one with the UART transmit function. The first parameter the function takes is the UART handle type diff, it's UART2, and I point it to that. And the second parameter is the data pointer, or the data array. And the third parameter is the size, which is transmitting 20 bytes, and then the timeout. I'm just going to give it 1 milliseconds timeout. And I want to do this every 1 second. And now let's test this one to start off with before writing the second thread. So let me compile the code. Okay, compiled without any errors. Now let me load it to the board. And now let me open my cell terminal to test this. So I'm going to use realterm for that. Open realterm. And on realterm, go to port, and it's port 3 already opened, and the baud rate is 115200, and click change. And now let me reset my STM board. Alright, very good. I can see the hello from thread 1 working. Good. And now let me write the code for thread 2. On thread 2, what I'll do is that I'll check the status of the push button, and then I'll transmit another thing over UART. And this is how to check for the push button. So it's on port C pin 13. I'm using the HAL GPIO read pin. If the push button is equal to reset, because push button is active low, then I want to transmit something else over UART. So I'm just going to copy the code over to here. I'm going to transmit, it's a local variable. I want to transmit hello from thread 2 now. So it's going to be the same code. And I'll put a delay of 400 milliseconds perhaps between each press. And this is without Mutex. So let's test this one. So let me compile the code, load it to the board. But I don't expect this one to get into any problem because the delay between them is large enough. But let's see what we get. Back to our terminal, let me open the port and reset my STM board. So I get hello from thread 1. And when I press the button, I get the hello from thread 2 without much problem really. Now what I'll do, I'll make a change in the code. I'll make the delay exactly the same, and that's where the problem should appear. Okay, when I make them the same, they both will try to transmit at the same time. So let me compile the code now, load it to the board and back again to my terminal. On my terminal, open the port again, reset my STM board. And you see hello from thread 1, absolutely fine. When I press the button, the problem starts here because both has got an OS delay of 1000 and they're trying to transmit at the same time, and it just corrupts the entire thing. Okay, and to eliminate this problem we need to use Mutex, and to use Mutex there are two functions, Mutex take and Mutex give. So you call the Mutex take before you handle it to the UART line, and then you call the X Semaphore give after you finish using the resource. So, and my Mutex name is not XMutex, it's defined above by CubeMX. I gave it the name URTMutex, and it's called URTMutex handle. So I need to pass this as a parameter here, and the port max delay is that it's going to wait indefinitely for the UART resource to be available, and then when it finishes using it, it's going to release it. And the same thing for the other thread as well. So this one will call in the Mutex to use UART. And the Mutex will add this one to the queue. As soon as UART2 is available, it's going to give it to thread number 2. And one more thing I want to do is that I want to increase the timeout for the UART transmit to 5 milliseconds to give it sufficient time to complete the transmission. And let me compile it and load it to the board. And we're going to have a look at the serial terminal to test it now. Okay, so I'm getting the hello from thread 1. Now when I press the button, I get hello from thread 2. Perfect, without any issue. And now let me show you how to create another thread manually, and also how to signal between threads. Signaling between threads is extremely useful. It's a very important thing you need to learn. It's notifying from one thread to the other. So to add a thread manually now, I need first to define a handle for it, a thread ID. So I'm just going to copy this and I'll change the name to task 3. And I'd need to create a function prototype for the thread definition. I'll call it thread 3. This is where the code for the thread gonna go in the function definition. And I also need to create the thread using this code and start it. So I'm going to copy this and I'll put it in the user begin. Putting it between the user begin and end will keep it there when you update CubeMX project, otherwise it will be deleted. So I'll call it my task 3 and it's thread 3, task 3, and the handle is task 3 as well. I'll keep the priority as default and the stack size same as well. Next I need to define the function definition of the thread. So I'm just going to copy thread 2 and I'll change the name to thread 3 because that's what I called it at the top. I called it thread 3. And on thread 3 I'll transmit the same text but with hello from thread 3 just to test it to start off with, and then I'll use thread signaling to signal to thread 3 to transmit when the button is pressed as well. So I'm transmitting the same one except at thread 3, the same size and the same function. I'm using the Mutex here as well in a similar manner, and I want to transmit this every 1.5 seconds. So let me compile it, load it to the board and back again to the terminal. Okay, good. So I'm getting hello from thread 1 and thread 3 as well, so it's working good. And when I press the button, I get the hello from thread 2. Okay, superb. And now let me show you how to signal between threads. So I'm going to notify thread 3 from thread 2. So as soon as I push the button, it's going to trigger for this one to transmit the hello from thread 2, and it's also going to trigger for this one to transmit the hello from thread 3 too. So to send a notification, we need to use a function called notify, xtask notify, and this function takes many parameters. It takes the thread handle, so I'm notifying to thread 3, so I need to pass the thread 3 ID handle, and it's defined at the top, and I called it my task 3 handle, so I need to pass this one as a parameter to the function. And the second parameter is the flag that you want to set. So you can set up to a 255 up to 8 flags, sorry, and I'm setting flag number 1, and ESET bit means that you're setting flag number 1 instead of resetting it. And on thread 3 I need to use notify wait function to wait for the notification to arrive and then proceed. So the function is called task notify wait. P defaults mean don't reset the flags on entry. 0xff mean reset all the flags when you leave this function, and notify value is the value that we received from the notification, which is 0x01, and port max delay means that wait indefinitely for the notify to arrive, and notify value is an unsigned 32-bit variable that I need to define in my thread here, and I give it the name notify value. And then I need to check if the notify value include the flag 0x01. So I'm going to use this if function, if condition. So if the notify value include 0x01, then I want to proceed and transmit the hello from thread 3. So I'm going to put this one inside the condition blocks. And we don't need the OS delay. So what's going to happen now, this one will wait indefinitely for the trigger from thread 2 to arrive, and then it's going to transmit hello from thread 3. Alright, so let's compile the code, load it to the board and back to our terminal. Right, so open the port again, clear the window, reset the Nucleo board. Okay, so I get hello from thread 1. Now when I press the button, I expect 2 hellos from thread 2 and from thread 3. Very good. Alright, perfect. Okay, so that's all for today's tutorial. I've shown you how to use FreeRTOS, how to define a thread manually, how to use Mutex, mutually exclusive Semaphore, and how to notify between threads. Right, so thank you for watching, and if you found the video helpful, don't forget to like and subscribe. Thanks, and I'll see you next time. Bye.